This video is for section 11.2 in Pre-Calc. So in this section, we'll be using dividing techniques to evaluate limits and rationalizing techniques to evaluate limits, and then we'll be doing some of them in our calculator. So dividing out technique is when you have a problem like this, which we're going to do in a moment. This is actually the first example we're going to do. If you try to do substitution on this problem, you would have -3 squared. So I'm just substituting in x equals -3 in all of these locations. So I'd have -3 squared minus 3 minus 6 over -3 plus 3. So you can see in my denominator, I would have a 0, which right away makes it undefined because you can't have a 0 in the denominator of a fraction. And then on the top I have, this is -9. -3 squared is +9. So this all simplifies to 9 minus 9, or 0. So I have 0 over 0, and we call that an indeterminate form because you cannot determine if the limit exists. So then we look at some different techniques like the dividing out technique to do this. And then also this is, like we did a little bit of this in 11.1, where you can check as you get closer and closer to -3. This would be from the right side. This would be from the left side. And take a look at what number you're approaching. Again, you would not be able to substitute -3 into this function. You'd get an error message because you'd get a 0 in your denominator. But you can kind of look at this and see from the right side and the left side, it looks like my limit is 5. So we're going to show algebraically how you can find out that that limit is, -5. So the first, always when you do a limit, the first thing you want to try is direct substitution. And that if that does not work, the next technique you want to try is simplify this by factoring. And if you look at the top, it's a trinomial, it's a quadratic, and that can be factored. So I'm going to factor the numerator. So remember, proper limit documentation requires that you write this until you've actually taken the limit. If you factor the top, it factors into x plus 3, x minus 2, and then on the bottom, I have an x plus 3. So if you remember your rational unit from Algebra 2, everything in the numerator is multiplied. So I can say x plus 3 divided by x plus 3 is 1. So now I have the limit as x approaches -3 of just x minus 2. Now I can do direct substitution. Let x equal -3, and I get -5. Okay, so for all limits, first thing you want to try is direct substitution. If that doesn't work, then try factoring if it looks like a function that can be factored. All right, this is for you to try. Again, I'll tell you right now, if you do direct substitution on this, you're going to get indeterminate form of 0 over 0. We'll just say that if you substituted. So factor and solve this to find the real limit. Pause the video and try this one, and then that will be your answer right there. Okay, example 2. Hopefully you got that you try, and that all went well. Let's look at example 2, and you might be looking at this going, I don't know if I remember how to factor that. So let's do a little review here, the way we're going to factor this. First of all, notice it has 4 terms. And if you look at these first 2 terms, you could factor out a common factor here. So the technique I'm going to be reviewing here is factoring by grouping. All right, so I'm going to start with x to the 3rd minus x squared plus x minus 1. So if you have these 4 terms, you can kind of, whoops, that should be an x. and kind of like separate it almost into two groups. So out of these first two terms, I want to factor out that common factor of an x squared. Both of these terms, this term has 3 x's, this term has 2. So what do they both have in common? 2 x's. So x to the third, if I factor out an x squared, I'm left with an x, minus x squared. If I factor out an x squared, I'm left with a 1. All right, now I'm going to rewrite this. These last two terms I'm going to put in parentheses. Now, if you think about this as your new expression here, remember terms are separated by pluses or minuses. So this is one term and this is another term. If I look at these two terms, they have a common factor. If I had copied this right, they have a common factor of x minus 1. So now I'm going to factor out that common factor of x minus 1. And remember, factoring out is just like dividing. So I'm dividing both of these terms by x minus 1. If I divide this term by x minus 1, I'm left with an x squared. If I divide this term by x minus 1, I'm left with a 1. So this, what we started with up here, all factors into this. Okay, so now let's see what our limit is. Limit as x approaches 1 of x minus 1 over x minus 1 times the quantity x squared plus 1. X minus 1 divided by x minus 1, 1 out. So now I have the limit as x approaches 1 of 1 over x squared plus 1. Now I can do direct substitution, replace the x with a 1, and I get 1/2. So again, I want to point out the documentation. Notice I write this limit every time. I'm using arrows between because I'm just continuing to simplify here. Once I do the substitution and get the limit, then I put the equal. So until you actually are taking the limit, you have to write this documentation every single time. All right, so a little factoring by grouping review there. And of course, one for you to try. So pause the video. Try this one, practice a little factoring by grouping. I'm going to give you one little hint before you start this one. This one, the first two terms have a common factor and the second two terms have a common factor. So give that one a try. You should get that for your answer. Yeah, I think I'll keep going and do the next example. So the next one is called the rationalizing technique, another common technique for evaluating limits. This is what you're going to see in your equations. You're going to see some square roots, and you might even have, I think I'm losing my lead here. You might even have more than just an x under that square root. You might have something like this, x plus 1, and then maybe something added onto the end. So a little review of what a conjugate is. This is an example of a conjugate. It's identical, except for the sign in between. This is x squared plus 4. The conjugate of, square root of x plus 4. The conjugate of the square root of x plus 4 is the square root of x minus 4. Conjugate of this one would be a minus in between there because this has a plus. What happens when you multiply by the conjugate? Your middle terms, you know, if you're thinking FOIL, you multiply your first two terms, your square root goes away. When you multiply your outside terms and combine it with your inside terms, those add to 0. So it ends up simplifying your limit nicely. This is the first example for the rationalizing technique. So you're going to want to copy that. Again, when you start this one, if I substitute 0 in here, I'd have 0 in the denominator. If I put 0 in here, I'd have 0 plus 1, which is 1. Square root of 1 is 1. 1 minus 1 is 0. So I would get 0 over 0 for this. So I cannot do direct substitution, although that should always be the first thing that you try. All right, now I am going to use the conjugate here to simplify this. And I'm going to kind of do this simplifying right next to this. So what you want to do is think the conjugate of this would be square root of x plus 1, all under the square root, and then plus 1. So that's the conjugate. I want to multiply the top and the bottom by the conjugate. I actually have to multiply the top and the bottom by the conjugate. I'm really just trying to simplify the top. But if I multiply top and bottom by the same thing, that's the same as multiplying by 1. So I'm not really changing this expression. I'm just rewriting it a different way that will then allow me to take the limit. All right, so now I'm going to recopy my limit here. So on the top, you want to think I'm multiplying a binomial times a binomial. So I want to do FOIL on this. I want to multiply the first two terms, the outside terms, the inside terms, and the last terms. I'm going to put a big fraction bar here because I'm going to need it. So square root of x plus 1 times square root of x plus 1, right? That's like this. That's what I'm doing. That just equals x plus 1. So I've gotten rid of that square root in the numerator. So that's x plus 1. The outside terms are square root of x plus 1 times 1. The inside terms are negative square root of x plus 1. That's always going to happen when you multiply by a conjugate. Identical term here and here, 1 plus, 1 minus. Those middle terms will always add to 0. That's why we do this. Last times last is negative 1 times 1, which is negative 1. And then on the bottom, don't multiply anything out on the bottom. You'll see why in a minute. Just leave it exactly like that in your denominator. All right, let's keep simplifying. I have not taken the limit yet. I don't know why I put an n here. That should have been an x. So keep writing limit. These combine to 0. So on the top, I have x plus 1 minus 1 all over x times the square root of x plus 1 plus 1. Okay, keep simplifying. Here in the numerator, I'm just going to have an x now. And then in the denominator, just copying that, really no change there. Now, if you look at this, x divided by x, those 1 out. And now, can't really simplify anything else, so I'm going to try doing substitution. So if I substitute in here, I have a 1 on the top. I have the square root of 0 plus 1 on the bottom, plus 1. So that is square root of 1 is 1. 1 plus 1 is 2. So the limit of this is 1/2. So step 1, multiply top and bottom of your fraction by the conjugate, which is this identical binomial, but change that minus to a plus. You're going to be foiling wherever you're multiplying by that conjugate. Your outside terms and your inside terms will be opposites and will add to 0. When you multiply the two square roots, your square root will go away. You'll be left with what's underneath it. And then you should, after that, be able to take the limit. Here is the problem that we just did in graphical notation. You can see that when x equals 0, we have a hole. The graph is undefined there. But if you looked at the y value that you end up when you approach x equals 0, it's 1/2. Okay, this is yours to try. I don't think the answer is on here. See if I can get you that answer. I do not have the answer for that, so I can give you that in class. The other thing you could do is graph this and see if you can, just like what they did up here, see if you can see the answer. Check your work by graphing. Okay, I'm going to finish this lesson in another video.